Good afternoon, class. Today we are going to learn about water, specifically how water gets from rivers and streams into your faucet. Our lesson today is titled From the River to Your Faucet. Our objective for this lesson is based on California Content Standard 4.4.7, which states trace the evolution of California's water system into networks of dams, aqueducts, and reservoirs. After completion of this lesson, you will be able to successfully describe and identify the evolution of California's water system. Now, let's start learning about water. There is water all around us. Did you know that some of it we cannot drink unless it is cleaned? Water can be found in oceans and lakes, rivers, streams, and even underground. So have you ever wondered about the water you drink? Have you ever thought about how it gets into your faucet or where it actually comes from?
How does drinking water get to your home?
Wow, I'm not really sure.
Probably through a series of pipes.
Pipes.
Pipes
And all that?
through pipes.
I have no clue.
I assume it comes up through the pump in the ground.
Through a filter?
Gets to a house with a pump, water pump.
Let's talk about California drinking water. Where does California drinking water come from? The drinking water here in Central Valley comes from many different resources. Our water can come from various water projects, the Colorado River, local streams, reservoirs, and even underground aquifers. How does our water travel, you may be asking? Our water actually travels a long way to get to our houses. In fact, most of the water that comes into California can be found in the aqueduct. So what is an aqueduct? The aqueduct is a large concrete canal which allows water to flow from the water projects, rivers, streams, reservoirs, and underground aquifers into a water processing plant.
Our water may come from Mother Nature, but it's far from pristine. It starts its journey to the treatment plant through a water intake pipe. On the wall of that pipe, about 2 meters down, is a 15-centimeter hole. Covering that hole is a metal grill designed to keep out large debris such as tree branches. The water flows to a pumping station where it goes through a preliminary screening. A giant revolving screen removes fish, garbage, and grass.
Let's talk about the water processing plant. Do you know what happens at a water processing plant? A water processing plant works hard to turn the water from water projects, rivers, streams, reservoirs, and underground aquifers into drinkable water. As water enters the water processing plant, it goes through many stages of cleaning before we can drink it.
The first step in the cleaning process removes sediment and particles from the water with the help of coagulants.
What?
Coagulants are chemicals that act like magnets. They cause particles in the water to stick together. These groups of particles are called flock.
I didn't know I had it in me.
American Water uses two common processes to separate and remove flock from water. One sinks flock to the bottom of a tank. The other method pumps air into the water and flock, causing residual particles to float to the top. The separation of water and flock is called clarification. With either method, the clarification process removes most of the flock from the water. The next step? Filtration.
Whoa! Hey, watch it! Wow! Can a water droplet get a bruise? Sheesh! Ow! Wow! I just got pushed through layers of activated carbon, sand, and gravel. Please tell me I'm clean.
Yeah, sorry, Splash. You're not completely out of the water. You're filtered, but you might be infected with tiny microorganisms. Don't worry. Disinfection doesn't hurt. Chlorine and ozone are just two of the ways we disinfect water.
Now what happens? Once your water's been through the processing plant, it still isn't ready to drink. So what happens next, you might be wondering? Well, your water goes through a disinfection process. The disinfection process removes any bacteria that might be in the water. The disinfection process involves the use of chlorine and ozone. How is your water disinfected? And what is the ozone? These are some questions you might be asking yourself, but we're going to learn more about that in the next slide.
I love chlorine. It's been disinfecting water and keeping me clean for over a century. But what's ozone?
Ozone is supercharged oxygen. These bubbles scrub and disinfect. Viruses, germs, and fungi don't stand a chance.
Whoa! Hey, that tickles! Stop it already! I'm gonna wet my pants!
Hey, Splash, guess what? You're finally drinking water, ready for distribution to homes and businesses.
Now that you've learned about how the processing of water works, I bet you're still wondering how it gets into your faucet. Once water's been disinfected, it is pumped through large pipes which run underground. These pipes lead to the street in front of your house. Outside of your house is a water valve which allows the water to flow underground into smaller pipes that are connected to your house. These pipes are connected to even smaller pipes which are connected to your faucet. And that's how the water gets into your house. Let's take a closer look at the water treatment process. Here in this picture, you can see that first the water comes into the processing plant and coagulation begins to help remove the flock. It goes through the mixing stage, which helps the flock fall to the bottom of the tanks. Then it goes through a filtration stage, which removes the rest of the flock, and then into the disinfection tanks before it is distributed to everyone. In summary, water travels from rivers, streams, reservoirs, and underground aquifers into the aqueduct. From the aqueduct, water then flows into large intake pipes, which cleans out debris from the water. The water then begins the clarification process to remove flock. Flock is harmful stuff found in water. This is a two-step process. First, clarification with coagulation, and then filtration. But wait, water isn't clean just yet. It still needs to be disinfected. The disinfection process is done using chlorine and ozone. Ozone is a process which uses air that's pumped into water to form bubbles. The chlorine and ozone remove any bacteria that's left in the water. Now, water is ready to drink. Now it's time that we check for understanding. These are some true or false questions. True or false? You can drink water from any lake, river, or stream before it's processed. True or false? California water comes from many different resources. True or false? Most of California's water can be found in the aqueduct. True or false? The aqueduct is an underground body of water. True or false? The water enters the processing plant through a large intake pipe. True or false? The water intake pipe removes fish, garbage, and grass. True or false? Water is drinkable once it goes through the water intake pipe into the processing plant. True or false? Water only has to go through a one-step cleaning process before you can drink it. True or false? Once water enters the processing plant, it only has to go through the clarification process before you can drink it. True or false? To get clean drinkable water from the processing plant, it must go through the disinfection stage. How do you think you did on those true or false questions? Well, let's check your answers. Question 1 is false. Often water from lakes, rivers, and streams have bacteria in it, which has to be cleaned out before you can drink it. Question 2. It's true. California's water supply does come from many different resources. Number 3 is true. Yes, most of California's drinking water does travel through the aqueduct. Number 4 is false. The aqueduct is not a body of underground water. In fact, it looks more like a river or stream. Number 5, true. Yes, water does enter the processing plant through a large intake pipe. Number 6 is true again. Yes, the intake pipe does remove fish, garbage, and grass. Number 7 is false. Water isn't drinkable until it has gone through the complete water purification process. Number 8 is false also. There are many steps that water must go through before you can drink it. Number 9 is also false. Water also has to be purified and then disinfected before you can drink it. And number 10 is true. Yes, the last stage of the water purification process is to disinfect the water. Now let's do a follow-up activity. On a sheet of drawing paper, draw and label the process which water goes from a natural resource into the processing plant. You must include pictures of what happens in the processing plant. This should include the clarification process, the removal of flock, and the disinfection process. Then draw how it flows from the pipes into your home.